So welcome guys, today we'll be starting the basic, the intermediate and the advanced levels of Python. We will be studying machine learning, how and what it's done, what is it, how it's done, and we'll perform a basic and major project that will show you all how do we do it. So let's talk about what's machine learning. Machine learning is used in internet search engines, email filters to sort out spam websites to make personalized recommendations, banking softwares to detect unusual transactions, and lots of apps on our phones such as voice recognition. The technology has many more potential applications, some with higher stakes than others. Future developments could support the UK economy and will have a significant impact upon society. For example, machine learning could provide us with readily available personal assistant to help manage our lives. It could dramatically import the transport system through the use of autonomous vehicles and the healthcare systems by improving disease diagnosis or personalizing treatment. Machine learning could also be used for security applications such as analyzing email communications or internet usage. The implications of these and other applications of need to be considered now and action taken to ensure uses will be beneficial for society. Machine learning is distinct from but overlaps with some aspects of robotics. Robots are example of the hardware that can use machine learning algorithms, for instance, to make robots autonomous and artificial intelligence that have a great definition. However, machine learning is a way of achieving a degree of AI. So let's see what is it. Right now we were having machine learning intro, but we do not know the in-depth of what is machine learning, how is it used, what is it actually. Resurging interest in machine learning is due to the same factors that have made data mining and Bayesian analysis more popular than ever. Things like growing volumes and varieties of available data, computational processing that is cheaper and more powerful, and affordable data storage. All of these things mean it's possible to quickly and automatically produce models that can analyze bigger, more complex data and deliver faster, more accurate results than even on a very large scale. And by building precise models, an organization has a better chance of identifying profitable opportunities or avoiding unknown risks. So, what is required to create good machine learning systems? We can say that data preparation capabilities, algorithms that are basically basics and advanced, basic to advanced, and also complaining or trying to modulate the data, algorithms and iterative processes, scalability, and assembling models. This is what will create a good machine learning system. So, who's using it? Let's have some applications of machine learning. So, as we can see on the screen, we can say it is also used by automatic language translation, such as the Google AI, the voice assistant, Alexa, Siri. All these use machine learning to see your daily life analysis into what you are searching and what would be relevant for them to show you on the screen. Medical diagnosis, such as diagnosing skin cancer or heart breast cancer through pre-learned data model sets. Stock market trading, online fraud detection, virtual personal assistant, email spam and malware, filtering, self-driving cars such as Tesla. The company Tesla has made a drastic improvement in self-driving cars and shows us how the future would be. Product recommendations, traffic prediction, speech recognition, and image recognition. This is just a name to few. Let us go an in-depth dive and see what these are actually. So, most industries working with large amounts of data have recognized the value of machine learning technology by gleaning insights from this data, often in real time. Organizations are able to work more efficiently or gain an advantage over competitors. To name a few, we can say financial services, banks, and other businesses in the financial industry use machine learning technology for two key purposes: to identify important insights in data and prevent fraud. The insights can identify investment opportunities or help investors know when to trade. Data mining can also identify clients with high risk profiles or use cyber surveillance to pinpoint warning signs of fraud. Government Government agencies such as public safety and utilities have a particular need for machine learning since they have a multiple source of data that can be mined for insights. Analyzing sensor data, for example, identifies ways to increase efficiency and save money. Machine learning can also help detect fraud and minimize identity theft, such as the India Aadhaar card system. Healthcare Machine learning is a fast growing trend in the healthcare industry. Thanks to the advent of wearable devices and sensors, such as the Apple Watch that tells you the required time or can inform the 911 emergency services if you have any sudden risks such as a heart stroke or a heart attack. So this technology can also help in medical expert analyze data to identify trends or red flags that may lead to improved diagnosis and treatments. Retail websites recommending items you might like based on previous purchases are using machine learning to analyze your buying history. Retailers rely on machine learning to capture data, analyze it, and use it to personalize the shopping experience, implement a marketing campaign, price optimization, merchandise supply planning, and for customer insights. Oil and gas industry. So, finding new energy sources, analyzing minerals in the ground, predicting refinery sensor failure, streamlining oil distribution to make it more efficient and cost effective. These are a few number of things. Oil and machine industry use it to gain their own profits from the everlasting machine learning technology. The number of machine learning use cases for this industry is vast and still expanding. Transportation. Analyzing data to identify patterns and trends is the key to the transportation industry, which relies on making routes more efficient and predicting potential problems to increase profitability. The data analysis and modeling aspects of machine learning are important tools to delivery companies, public transportation, and other transportation organizations. So now we have learned about machine learning. What is it and what are the applications of machine learning? We now know where is it used, how is it used, and how if you want to create your own company or an organization, you can use it for your own benefit. So machine learning is not basically limited to a number of people or some scientists that are working in an R&D group, but it can be used by any organization from basic general stores to the high organization industries or the big industries for their own profits. Now since we have seen the machine machine learning uses. Let's see machine learning in action. Let's learn about it. So Python community has developed many modules to help programmers implement machine learning. In this article, we will be using NumPy, SciPy and skitlearn modules. We can install them using cmd command pip install numpy, SciPy, skitlearn. Let me show you. So if we act as cmd, run as administrator, first we write pip install. If you are writing like this, let me show you. NumPy, SciPy, skitlearn. You see that it starts downloading the skitlearn, installing, collecting packages and so on. While it's installing, let's have a further look. So you can see that it installed here and it says that you are using version this and I need to update it. Leave it, or let's leave it all. But you can see that if you are getting an error, you need to check out the web handles and the web pages available on Google, or else you will get a screen something just like this. So machine learning overview, let's have a look over it. So machine learning involves a computer to be trained using a given dataset and using this training to predict the properties of a given new data. For example, we can train a computer by feeding it 1000 images of cats and 1000 more images which are not of cat, and tell each time to the computer whether a picture is a cat or not. Then if we show the computer a new image, then from the above training, the computer should be able to tell whether this new image is a cat or not. The process of training, prediction, and training and prediction involves the use of specialized algorithms. On the basic level, we use the algorithm known as brute force, using one by one and training the computer. We feed the training data to an algorithm and the algorithm uses this training data to give predictions on a new test data. One such algorithm is k-nearest neighbor classification, or the KNN classification. It takes us test data and finds k-nearest data values to this data from test dataset. Then it selects the neighbor of maximum frequency and gives its properties as the prediction result. Testing the dataset. Now we have dimensions of a new flower in a NumPy array called xnew, and we want to predict the species of this flower. We do this using the predict mod method, which takes this array. We know it as KNN. So we take the array as an input and spit out the predicted target value as output. So the predicted target value comes out to be 0, which stands for Setosa. So this flower has good chances to be of Setosa species. Finally, we find the test score, which is the ratio of number of predictions correct and total predictions made. We do this using the score method, which basically compares the actual values of the test set with the predicted values. So till now we saw how to set up the environment. Let's see the process. The process involved a basic breakdown of what happens when we are learning machine learning and what happens to the machine, how are the things. So the first step here is importing and cleaning data. Whenever we are starting out with data science, we first need to identify or clear out a more standardized, or we can say a more trusted source of that data that can provide us a near to clean data. But we know that that data is not cleaned, because whatever trusted source or how big it may be, that cannot have clean data, because that is not how the input came. The input came by a user which didn't have an order and not was a machine, but used the data in a haphazard manner, or we collected the data in a way that was set according to the machine and not according to the values or the data sets that we are focused on. Next, the step B, we have splitting the data into training sets. So what does it mean to split the data into training sets? So the train and testing procedure is used to estimate the performance of machine learning algorithms when they are used to make predictions on data, not used to train the data. It's a fast and easy procedure to perform, the results of which allow you to compare the performance of machine learning algorithms for your predictive modeling problem. Although simple to use and interpret, there are times when the procedure should not be used, such as when you have a small data set, and situations where additional configuration is required, such as when it is used for classification and the data set is not balanced. So the train test split is a technique for evaluating the performance of a machine learning algorithm. It can be used for classification or regression problems and can be used for any supervised learning algorithms. If you don't know, we have three algorithms: supervised, unsupervised, and machine learning algorithms. The first subset is used to fit the model and is referred to as training dataset. The second subset is not used to train the model. Instead, the input element of the dataset is provided to the model. Then predictions are made and compared to the expected values. This second dataset is referred to as the test dataset, used to fit the machine learning model, and the test dataset used to evaluate the fit machine learning model. So when to use the train test split, the idea of sufficiently large is specific to each predictive modeling problem. It means that there is enough data to split the dataset into train and test datasets, or we can say that each of the train and test datasets are suitable representations of the problem domain. This requires that the original dataset is also a suitable representation of the problem domain. A suitable representation of the problem domain means that there are not enough records to cover all common causes and most uncommon cases in the domain. This might mean combinations of input variables observed in practice. It might require thousands, hundreds of thousands, or millions of examples. Next, the step C, we are creating and training the model. So now when we have imported and cleaned the data, we have split up and trained the data for making, not actually training the data, but for just machine learning algorithms to speed them up. Now we will be actually creating and training the model. In this, the machine learns how to create a separate algorithm if needed, or use the most sufficient and efficient training model or algorithm to solve the problem. It uses those training models to solve the problem efficiently while also keeping the data set in an ordered manner to provide desired results. Next, the step D, we have making predictions. Now we have trained the computer what to do when excuse me, when a particular data set or a particular value is stored. So now we start using it as an output source, that is using it as a machine. Like for an example, we have trained the machine of a thousand pictures of cats, that this is a cat, this is a cat, this is a cat. And the next thousand pictures we have created or trained the machine that this is not a cat, and we have imported the photos of horses and said that this is not a cat. Now we provide now we provided a photo of a fish. The machine, if trained properly and cleaned and imported data properly, the things and the predictions will make true that this is not a cat. And the next, if we put any cat image such as a black cat, a white cat, or anything, we get the prediction as that it is a cat. After making these predictions, we evaluate and improve the data element, that is set E. Suppose there are some errors in the program or in the algorithm, in which if there is a cat image, the program is showing that it's not a cat image, or if there is a image of a lion and it's saying it's a cat, but we know that there are similarities between it, but we know that it's not a cat. We will eventually evaluate and improve according to the new data that is being provided. So it's never a learning stop learning project. It always, the machine always keeps learning and learning until the eternal. This keeps the machine learning becoming efficient and more efficient with the time passing by. Six. So now we have learned about how, what is machine learning, what is it, how is it used, and how is the data collected and stored. Let's have a look at some libraries. The first library we have here is NumPy. So NumPy can be used to perform a wide variety of mathematical operations on arrays. It has powerful data structures to Python that guarantee efficient calculations with arrays and matrices, and it supplies an enormous library of high-level mathematical functions that operate on these arrays and matrices. Pandas. Data frame is a two-dimensional size, mutable, potentially heterogeneous tabular data structure with labeled axes, rows, and columns. A data frame is a two-dimensional data structure, that is, data is aligned in a tabular fashion, that is in rows and columns, such as in an Excel sheet. The next third one is the matplotlib. So the matplotlib or a pyplot is a collection of functions that make matplotlib work like MATLAB. If you don't know about MATLAB, it's a programming language that is used by basic levels of MS-DOS and basic work functions to evaluate and to evaluate data into a more visual and graphical representation. We can have an example of the Pringle chips that we eat. It was the shape of the chip was basically formulated through the MATLAB. So each pyplot function makes some change to a figure. Example, creates a figure, creates a plotting area in a figure, plots some lines in a plotting area, decorates the plot with labels, etc. Thank you. Now, since we have had a look about what's machine learning and what are the libraries, let's have a look at what we will be using for our machine learning project. So, first we open Anaconda and we open a Jupyter notebook. Let it load a bit. Depending on your processor type, the Anaconda environment and the Jupyter environment opens its page. So we see here the local host 888 4 times 8 slash 3. This is the dashboard of Jupyter. If we want to create a new Jupyter notebook, we click on new and you can see here Python. So Python 3 is what we click. Takes a while, and now we are inside the Jupyter notebook. If you want to create a distinct name, we create it as test subject 101, and it's the same as Python. All the functions of Python work here. Suppose if you want to print hello world. If you click enter, it creates a line. But if you click F5, no. If you click run, it prints the world hello world. Same as if we studied tuples. Print tuples, print type tuples, and run. So here is the thing, you see that as we create tuple and we created and we have printed the tuple and also the class of that thing, that is tuple. So this is the environment we will be using for our basic data analysis and machine learning program. If you want to save it, just press the save, or you can see here that it's auto saved in a minute. So this is all for today. Thank you.
GM Beats.